Find dy by dx if y is equal to 1 plus sin x upon cos x. Now we differentiate with respect to x and apply the quotient rule or the division rule and obtain dy by dx. So differentiating with respect to x, we have dy by dx is equal to, we start with the denominator, so we have cos x into derivative of 1 plus sin x minus 1 plus sin x into derivative of cos x upon cos square x, or cos x the whole square, which is cos square x. Further, we have cos x into, now derivative of 1 is 0 and derivative of sin x is cos x. So we have cos x into cos x minus 1 plus sin x into derivative of cos x is negative sin x divided by cos square x. Now let us simplify the numerator. Cos x into cos x, that becomes cos square x, then minus sin x into 1, that's minus sin x, and this negative sign here, so this becomes plus sin x. Minus sin x into sin x is minus sin square x, and this negative sign makes it positive, so plus sin square x divided by cos square x. Now if we rearrange the terms in the numerator, we just club these two terms together, that is cos square x plus sin square x, and plus sin x, we write it separately, divided by cos square x. Now we know that cos square theta plus sin square theta is 1. So this value, that is cos square x plus sin square x, becomes 1. So finally we have 1 plus sin x upon cos square x. So this is the value for dy by dx. Find dy by dx if y is equal to 1 plus cos x upon sin x. Now we apply the quotient rule to obtain the derivative. So differentiating with respect to x, we have dy by dx is equal to, we begin with the denominator, that is sin x into derivative of 1 plus cos x minus 1 plus cos x into derivative of sin x, the whole thing divided by sin square x. So we have applied the quotient rule, and now we proceed further. Now sin x remains as it is, into derivative of 1 is 0 and derivative of cos x is negative sin x. So this will be sin x into negative sin x minus 1 plus cos x into derivative of sin x is cos x, the whole thing divided by sin square x. Now if we simplify this further, sin x into negative sin x is negative sin square x, And now we multiply these two terms, cos x into 1 cos x and the negative sign here. So that is minus cos x. Cos x into cos x is cos square x and the negative sign here. So that is minus cos square x divided by sin square x. Now this could be simplified further. We just rearrange the terms. We take the square terms together and also we take the negative sign common. So we'll have sin square x plus cos square x. So we have combined these two terms and taken the negative sign outside, and the third term is minus cos x divided by sin square x. Now we know that sin square theta plus cos square theta is 1. So this becomes negative 1. Then we have minus cos x upon sin square x. So this is the value for dy by dx. Find dy by dx if y is equal to x plus cos x upon 1 plus sin x. Now here we'll obtain the derivative applying the quotient rule. So let us differentiate with respect to x. So we obtain dy by dx equal to, now the quotient rule begins with the denominator. So we have 1 plus sin x into derivative of x plus cos x minus x plus cos x into derivative of 1 plus sin x, the whole thing divided by 1 plus sin x the whole square. Now proceeding further, we have 1 plus sin x into, now derivative of these two terms, derivative of x is 1 and derivative of cos x is negative sin x. So we have 1 minus sin x minus x plus cos x into derivative of these two terms. Derivative of 1 is 0 and derivative of sin x is cos x. The whole thing divided by 1 plus sin x the whole square. Now these two terms are of the form a plus b into a minus b, and hence this could be written as a square minus b square, that is 1 square, which is 1, minus b square, that is sin square x, minus, now this term remains as it is, x plus cos x into cos x divided by 1 plus sin x the whole square. Now we know that 1 minus sin square theta is cos square theta. So this becomes cos square x. Now we multiply this bracket by cos x. So we have minus x times cos x, x times cos x, and cos x into cos x is cos square x and the negative sign here. So we have minus cos square x, then divided by 1 plus sin x the whole square. Now cos square x and minus cos square x cancel out. So finally we have minus x cos x upon 1 plus sin x the whole square. So this is the value for dy by dx. Find dy by dx if y is equal to x square plus sin x upon 1 plus x. Using the quotient rule, we have now differentiating with respect to x, and using the quotient rule we get dy by dx is equal to 1 plus x into derivative of x square plus sin x minus x square plus sin x into derivative of 1 plus x, the whole thing divided by 1 plus x the whole square. Further, we have 1 plus x into, now derivative of these two terms, derivative of x square is 2x and derivative of sin x is cos x. So we have 2x plus cos x minus, now this bracket remains the same, that is x square plus sin x into, now derivative of 1 is 0 and derivative of x is 1, divided by 1 plus x the whole square. Now if we simplify this further, 1 into 2x is 2x, 1 into cos x is cos x, then x into 2x is 2x square, and x into cos x is x times cos x, and then we multiply these two terms. 1 into x square is x square and the negative sign here, so we have minus x square. 1 into sin x is sin x and the negative sign here, so that is minus sin x, divided by 1 plus x the whole square. Now 2x square minus x square, this becomes x square. The next term we could write is 2x. Next will be cos x. Next term will be x cos x, and the last term is minus sin x. The whole thing divided by 1 plus x the whole square. Further simplification could be done. We can just take x as the common factor over here. So we have x plus 2 within brackets. Now in these two terms we could take cos x as the common factor. So here we would be left with 1, and here with x and the common factor cos x. So here we have taken cos x as the common factor, and lastly we have minus sin x, the whole thing divided by 1 plus x the whole square. So this is the value for dy by dx.